All right, hello there. So these notes that I have here in this file cover 2 days of material, so we're not going to, of course, go over all of them here. We're just going to review a little bit on synthetic division, and I'm going to show you a long division problem. So you should have done synthetic division last year in Algebra 2, and so you would have seen a setup like this, and somebody would have asked you to divide. Remember, it's just a really quick and easy thing, so let me remind you what to do. So first you set it up like this. If you're trying to divide by x minus 5, you're trying to see if the number 5 is a root. You're trying to really divide it to see if 5 is a 0 on the graph. So let's take a look. So what you do, remember, you draw a little box and you put the number 5 in there. So it's really kind of like you put the 0 of whatever is down below here. So 5 would be the 0 of that expression right there. Whoops, keep messing up my markers here. There we go. All right, so I put a 5 there, and remember then I steal all the coefficients. There's a 1, there's a -3, a -8, and a -2. So I line those up, and there's nothing missing. It's x to the third, x squared, x, and then 2. So I'm going to line up 1, -3, -8, and -2. Leave a little space and draw a line. So remember, the first number comes straight down. So that's 1. And then I'm going to do a series of multiplications and additions. I'm going to multiply 1 times 5, and that goes right here. Then I'm going to add these two numbers and get a 2. And then I'm going to do it over again. 2 times 5 is 10. I'm going to put it here. I'm going to add, and I get another 2 actually. And keep going until I'm done. So let me go and write that in there now. So 1 times 5 is 5. I add these together, and then I get 2. 2 times 5 in the corner again is 10. Again, I add these, and I get a 2. 2 times 5 is 10. Add those up and get an 8. So remember, this guy right here, this is my remainder. So x minus 5 did not divide perfectly into this polynomial, x to the third minus 3x squared minus 8x minus 2. And so what did happen to me, though, is I did divide an x through, so everything has reduced to power. So this problem used to start with x to the third, so now it starts with x squared, and it trickles down x, and then nothing at all, and there's my remainder. So I would write my answer like this: 1x squared plus 2x plus 2, and then plus, because it's a remainder, 8 over what I was dividing by. So you always put this over what you were dividing by. Okay? And so you should actually officially write your answer to the side, and there it is right there. All right, so let's do a couple more. So this I'm dividing by x plus 1. So remember, I'm going to put a -1 in the little box. Now I am missing some terms. I have x to the third, so there's a 1x to the third. I'm missing x squared, so remember that I put a 0 for that. And then I have a -6x and a -5. So leave a little space, draw a line. 1 comes down. 1 times -1 is -1. Add, I get -1. -1 times -1 is +1. Add that column, I get -5. And then -5 times -1 is 5. Add that column and I get a 0. So when I get a 0, I'm very happy because that means my remainder was nothing. Just like with regular division, when your remainder is nothing, that means it divided perfectly. That means that the answer to this problem is this right here, a perfect answer, no remainder. This was x to the third, so remember I start off with x squared, then x, and again, no remainder. So what that also tells me is this, that x to the third minus 6x minus 5 is really just x plus 1 times x squared minus x minus 5. So what it's helped me do is it helped me factor. Okay, because remember, like just back in like regular old math, like if you take, I don't know, 10 divided by 2 and the answer is 5, well then you also know that 10 is 2 times 5. So that's what I just did right here. I now know, since it divided perfectly, that what I was dividing with times my answer equals what I was trying to divide things into. All right. So let me erase all those little markings because that was just to show you that stuff. All right, so let's go on. Just a couple more little examples here. This is a long one here. Let's see. So put a -5 in the box. I'm going to have 2x to the fourth, 7x to the third. There's nothing missing here. All right, leave a little space, draw a line. Okay, so bring down my 2, and I want you to tell me the next answer right here. I want to know what goes right there. All right, so if you watched, 2 times negative 5 is negative 10, so what goes right there is a negative 3. I hope you got that. Then keep going. Negative 3 times negative 5 is 15. Remember, I add, so negative 26 plus 15 is negative 11. Multiply again, get 55. Add those up, get 6. 6 times negative 5 is negative 30. So again, I'm very happy because I have a 0 remainder. So I go through and I write, this was x to the 4th, so I'm going to start off with x to the 3rd, x squared, x, and then I have my answer. So my answer would be, and I could write it up here, my answer is 2x to the 3rd minus 3x squared minus 11x plus 6. And there I go. It divided perfectly. Or you can write it down here if you like. All right. So one more thing we can do with synthetic division is this. All right, and one little trick you can use. So if I have to find this right here in this problem, that's going to be horrible. I got to plug negative 7 in here, do the 4th power. Who knows what the heck that is? Then I got to do it the 3rd power. Then I have this and the 1. So it's a lot of work to do. So what you can do is you can do synthetic division. If you put a negative 7 in the box right here, and you do your synthetic division, it's 1x to the 4th, 7x to the 3rd, put a 0 for your x squared because it's missing, and then a 1 and a 1. And just do these little multiplications and additions. So bring the 1 down. 1 times negative 7 is negative 7. That adds up to 0. So this is all very simple. 0 times negative 7 is 0. Add those up, get 0. Again, multiply, get 0. And then add that up to a 1. 1 times negative 7 is negative 7, and I get negative 6. And look at that. If you actually plug negative 7 into that big expression, you actually do get negative 6 if you try it on Desmos or your calculator or whatever. Okay? So that's a little trick you can use. You can use synthetic division to help you evaluate expressions for particular numbers. All right. So the last thing we're going to do is I'm going to show you a long division example. I think we'll just do one, and I'll save the other one for class, so not to make this too long. So here we go. So first of all, remember regular long division. So regular long division, you would have to do, like, let's say you're trying to divide, I don't know, 12 into, and you don't have to write this down, just kind of follow along. 12 goes into 4,965 or something. So you say to yourself, okay, 12 goes into 49. Well, 12 times 4 is 48, so I'm going to put a 4 up here. Then I multiply those, and I subtract. I bring down the 6. 12 times 1 is 12, so I'm going to use that. And then 12 times 1 is 12, so I'm going to subtract. Bring a 4, and then bring a 5 down. 12 goes into 45 only 3 times. And then that makes 36, so then I subtract, and my remainder is 9. And so there's all kinds of ways to write the remainder and so forth, but you're going to do it like we did earlier on the synthetic division problems. All right, so just remember that process of seeing what it takes to turn this into that, putting it down here, subtracting, and then bringing down the next term, okay? All right, so here we go. So x plus 7 is being divided into x to the 3rd plus 9x squared plus 9x minus 37. Now there's nothing missing, or I would have put some zeros in there, but there's nothing missing. All right, so this looks horrible, but it's not that bad. So you have to ask yourself, all you're going to do is use this x right here. This 7 over here, he's just following along. He's just like a tag-along guy. All right, so what do you multiply x by to make it x to the 3rd? So hopefully you can tell me that that's x squared. X times x squared is x to the 3rd. Exactly like I was doing over here. What do you multiply 12 by to make it look like 49, or close as you can? But in long division over here, we're going to be able to be perfect. All right, so x times x squared. So I'm going to put an x squared up here, and then I'm actually going to do the multiplication. Well, x times x squared is x to the 3rd, and then 7 has to follow. 7 times x squared is 7x squared. So I'm going to write that for real in a second. All right, so x squared times x is x to the 3rd. X squared times 7 is plus 7x squared. And then just like before, like you did over in this example over here, you draw a line and you subtract. So this is where you have to be careful. Now x to the third minus x to the third, those go away, and they should every time. But this is where you have to be careful. You have 9x squared minus 7x squared. So 9 minus 7 is 2. So 2x squared. All right, now I start over. I bring down the plus 9x, and I do it all again. So how do I make x look like 2x squared? Well, I'd have to multiply by a 2 and also another x. So that's my decision. So my decision is a positive 2x. So now I go with my decision. 2x times x is 2x squared. And then 2x times 7 is plus 14x. And then I draw my line and subtract. All right. So 2x times x is 2x squared. 2x times 7 is 14x. Line, subtract. So these go away. 9 minus 14 would be negative 5x. And bring down the 37. All right, so last step. All right, let's see. How do I turn x into negative 5x? Well, I would have to multiply by negative 5. So that's my choice. And then I do it. Negative 5 times x should be negative 5x. Negative 5 times 7 should be negative 35. Draw a line, subtract. Okay? All right. So let's see. That would be negative 5x. Negative 5 times 7 is negative 35. Draw a line, subtract. So these go away. Now this is where you have to be careful. You have a negative 37 minus a negative 35. So that really turns into plus right here. So you really have negative 37 plus 35. So that would be negative 2. And there's my remainder. All right, so just like always, we write our answer. I got x squared plus 2x minus 5. Plus or minus, it doesn't matter what you put, but my remainder is negative, so I should put a negative 2 over what I was dividing by, x plus 7. So you see my answer written right there. Another way you could do it is this. You could have x squared plus 2x minus 5 plus, and then just put a negative 2 over x plus 7. So if you want to write it like that, that's fine also. All right, so see you in class. Bye-bye.